This is pre-calculus section 5.4 on the sum and difference formulas. First of all, we're going to look at a couple of examples. Have your calculator in degree mode. Evaluate the left side of this expression, the cosine of 20 plus the cosine of 70, and compare that with the right side of the equation, cosine of 20 plus 70. You might want to pause this video and actually do those on your calculator. When you do that, you'll find that the left side is bigger than the right side. So it's actually in inequality, they are not equal to each other. Even though you have 20 and 70 for both those, these are not the same thing. If you tried problem number 2, when you had it in radians mode, you evaluate the left side, and then evaluate the right side and compare those. Once again, they're not equal to each other, and the left side is bigger than the right side. What I'd like you to notice about this is this. If you have the sine of x plus the sine of x, that's equal to 2 times the sine of x. In other words, we have these little coefficients out front of 1 sine of x plus 1 sine of x, and that gives us 2 sine of x. This, however, is not equal to the sine of 2x. We don't add those angles on the inside and keep just one sine out there. These are not the same. Likewise, if you have the cosine of y plus the cosine of y, that is equal to 2 times the cosine of y, but that's not equal to the cosine of 2y. Again, you don't add those angles together like that. However, we do have some formulas that allow us to add angles together when we're dealing with trig functions. We have this big chart here. This is a chart that you're going to want to know. And we have the sum and difference formulas for sine, cosine, and tangent. We have the cosine of alpha plus beta. And if we are going to evaluate this, alpha and beta are some angle, maybe like 30 degrees and 20 degrees, or pi over 2 radians and 3 pi over 4 radians. They could be any angles. And if we wanted to expand this out, we would multiply the cosines of the angles, multiply the sine of the angles, and then add those different values together. So using this as an example, the cosine of alpha plus beta is kind of similar to that, except it's going to be cosine alpha, cosine beta, with the sine alpha, sine beta. However, this plus sign now becomes a minus sign over here. And we're going to look at a big comparison of all these. We're going to have two columns. What is consistent and what is inconsistent about the way that these formulas work. First thing I'm going to say is that for the cosine sum and difference formulas, the consistent thing is that cosine is multiplied by cosine and sine is multiplied by sine. I would expect that to happen, and for the cosine sum and difference formula, it does work. Now the inconsistent thing is the whole idea of plus or minus. In the original part over here, we have a minus sign. However, when we have combined them together, it turns into a plus sign. Cosine of alpha plus beta turns into having a minus sign in there. Next up, what if we're using the sine function and looking at a sum or difference formula? Well, here's the first value of that. You can kind of compare it to what we had before. It's not exactly the same. Using this as my model, then I would expand out and say that the sine of alpha times the cosine of beta plus cosine of alpha times the sine of beta. And again, to help remember these, I'm thinking about what is consistent and what is inconsistent about the formula. This time, the consistent thing is the plus means plus and the minus means minus. In other words, we have a sine of alpha minus beta, and we're subtracting these two different products over here. The plus also means plus there. The inconsistent thing is that sine is multiplied by cosine and cosine is multiplied by sine. The last thing we have is the tangent sum and difference formula. And here is tangent of alpha plus beta. You can see how it's all expanded out. Maybe you want to take a moment and try to make a conjecture as to what do you think the tangent of alpha minus beta is equal to. Meanwhile, I'll go ahead and work that out. The numerator is the tangent of alpha minus the tangent of beta divided by, in the denominator, 1 plus the tangent of alpha times the tangent of beta. And like before, we're going to make some comparisons about what is consistent and inconsistent about this. And what I would say is that the numerator is consistent with what you would expect. Since there's a plus sign in here, we have a plus sign in the numerator, so the numerator is consistent. There is no other trig function, it's only tangent. That's kind of nice. And our inconsistent thing is going to be the denominator. So when I compare this one I'm looking at my original formula, I'm looking at the denominator, and those are kind of switched, if you will. There's a plus sign on the left and minus sign down on the denominator, so the denominator is our inconsistent part of this formula. Let's go ahead and look into some examples for this. First one, we have the cosine of 80 degrees. Now, I could pick any two numbers. What adds up to 80 degrees? Well, 60 plus 20, 10 plus 70, 79 plus 1. But if I'm using these two angles, and I want to know, well, what is the cosine of 80 degrees equal to? I could expand it out, and in the short term, in the temporary, make it slightly more confusing, because we're adding 50 plus 30, and it's a cosine sum formula. We're going to take the cosine of 50 times the cosine of 30 minus the sine of 50 times the sine of 30, and this again is our cosine sum formula. And if we were to evaluate all of this on the right hand side and compare it with the cosine of 80 degrees, it would be the same. Now again, this is expanding it, this is making it more confusing for the time being, but we're going to use these skills to eventually help us to simplify other problems. Next up, I have a condensing problem. Here's our initial problem, and we need to condense this and also simplify it as much as we can. My first observation is that we have two different products, and both of them have the same angles. There's a 70 degrees and a 40 degrees in both of them, but it's inconsistent in that sine is being multiplied by cosine. If I go back up to that formula sheet from before, the trig function that has the inconsistency is sine. The angles are 70 degrees and 40 degrees. But then the consistent thing, now that I've identified it as sine, the consistent thing is that a minus sign here means minus sign there. So this would all be equal to the sine of 30 degrees. 70 minus 40 is 30. And 30 degrees, I know that one. That's one of our special values. The sine of 30 degrees is equal to 1/2. So this initial problem that is over here, if you actually took out your calculator, multiplied and subtracted and did all that, it would come out equal to 1/2. So why are we going to do this? How are we going to use this? We have some exact values that we already know, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and we're going to use our knowledge of those exact values to calculate what is the exact value of the sine of 75 degrees. If you go to the calculator, type in sine of 75, it will give you a decimal, but we can find an exact fraction for this one. It's not very often that you can do these. There's only a few values that you can do this with. That's the 30, 45, and 60 degrees. But now we can find a way to find the exact value for the sine of 75. So first up, I'm looking at the number 75 and trying to figure out what variations of the numbers 30, 45, and 60 can we either add or subtract to get to 75. Well, 30 plus 45 is 75, so here's my first step. I'm expanding it out that way. Next up, I'll use the sine sum formula. So that means we're going to take the sine of 30 times the cosine of 45 plus cosine of 30 times the sine of 45. Again, this is from one of those formulas from before. Because we're expanding sine sum formula, the inconsistent thing is that sine gets multiplied by cosine, and then cosine times sine. But the plus sign stays the plus sign. That is our consistent thing. Next up, we're going to evaluate, and I chose those numbers on purpose because I know the sine of 30 degrees is 1/2. The cosine of 45 degrees is root 2 over 2, plus, and then the cosine of 30 degrees is root 3 over 2. The sine of 45 degrees is root 2 over 2. So now when we multiply these, that's root 2 over 4 plus root 6 over 4. And because those have the same denominators, we can combine those together to get root 2 plus root 6 over 4. This is the exact value for the sine of 75 degrees. If you put sine of 75 degrees in your calculator, it would give you a decimal. If you tried to hit math fraction, it wouldn't actually give you this because this is an irrational number because of the radicals in there. However, if you did evaluate this fraction on your calculator, it would be the same decimal equivalent as just typing in the sine of 75 degrees. So here's another type of problem that we're going to look at. There's a lot to take in this. So here is the given. We have the sine of angle alpha is 4/5. The cosine of angle beta is 5/13. These are two different angles. And then we're also given this information. Angle beta is between negative pi over 2 and 0. In other words, angle beta is in the negative quadrant 4. The other thing we're given in this huge long string of inequalities is that alpha is between 0 and pi over 2. In other words, alpha is in the positive first quadrant. So we're going to interpret both of those and make a drawing, and I'll go back to this angle beta first. So beta is between negative pi over 2 and 0, so it's down here. There's angle beta. It's always on the positive x-axis. The sine of this angle is equal, or the cosine of this angle is 5/13, so the adjacent over hypotenuse is 5/13. I'm taking it from that piece of information right there. And then using Pythagorean theorem, or recognizing that it is a Pythagorean triple, this is going to be a distance of 12. And because it's going down, I'm going to write it as a negative 12. Direction is important. So here's what we know. Combining these two things together, I have all of this. Next up, we're going to look at the angle alpha. Alpha is in quadrant 1, and the sine of alpha is 4/5. So drawing this one out, we're looking at the first quadrant, again, because of those restrictions. Here's angle alpha right on the positive x-axis. The sine is opposite over hypotenuse. There's a right triangle. All trig is based off of right triangles. We can expand beyond that, but here is an example of putting those two yellow things together. If you use Pythagorean theorem, this length is 3, and it's to the right by 3, so it is a positive 3. So now we have all of this. Just interpreting that, now let's actually go to the question. It says, what is the sine of alpha plus beta? I'll expand that out first using the sine sum formula. So sine alpha times cosine beta, that's the inconsistent. The consistent thing is plus sign means plus sign. Cosine of alpha times the sine of beta. So we have that. Now to plug in some values. The sine of alpha, we were already told that is equal to 4/5. Cosine of beta, we were told that was 5/13 plus. Now we weren't told the cosine of alpha, at least not yet. But if we look back at our drawing, the cosine of alpha is adjacent over hypotenuse, so I can see that's 3/5, times the sine of beta. Well, from our angle beta, negative 12 is the opposite, 13 is the hypotenuse, so negative 12/13 is the sine of beta. And then when we multiply these out, we get 4/13. And then multiplying this one, we get negative 36/65. When I multiplied the second one, I got this. I simplified the first one right away, thinking, oh, that's going to help me, but it really didn't, because now I don't have the common denominator. So if I go back over here and multiply these out without the simplification first, I'll see that this is actually 20/65. Now they have a common denominator, so if we combine them together, we get negative 16/65, and that is the sine of alpha plus beta. What does all this mean? It means if we had this actual angle measurement and this actual angle measurement and added them together, maybe like negative 40 degrees and positive 28 degrees, something kind of like that, we'd get a new angle, and for that angle, this would be the sine of that angle. This is part 1 of the notes.